Okay, section 1.4. We want to look at open, closed sets. So a set is open if all its points are interior points. So pretty much the idea here is, whoops. Well, that's supposed to be dots there. I got a little careless. If I pick any point in here, it's an interior point, and I'm not going to pick anything on the boundary. So that's an open set. So I can always draw some small open disk around it. Okay, so of course the open disk is an open set. That's kind of why it's called an open disk, I guess. Then a set is closed if it contains all its boundary points. Okay, so again, if I do a set like that, then that contains all its points, right? So a set could be neither open nor closed. Right? So, if I've got that much that includes the boundary, that much that doesn't, then not every point is an interior point, nor does the set contain all its boundary points. And so it could be neither open nor closed. Or for that matter, if you just got a bunch of isolated points, right? Those are not boundary points, and they are definitely not interior points. So there also is a set that's neither open nor closed. Okay. Let's see. And we should mention the empty set. Often denoted this way. In the complex plane, the empty set and then C are both open and closed, which is kind of strange, but yes, they are. Okay, and then finally we have our definition of the boundary of G and as a set. So we know about boundary points, but the boundary G like that. So this del G here of a set G is the set, set 1T, set of all boundary points. Okay, and now here's an interesting thing. Here's an example. There are many others. Actually, we didn't mention another one. I'll mention them both. So I'll say examples of math homographs. Now, you'd think that is a math term, but no, it's more of a language term. Homographs, okay, spelled the same. But different pronunciation or meaning. So they could be pronounced the same but have a different meaning. I guess they could have the same meaning but be pronounced differently. Now, to me, if they have the same meaning and are just pronounced differently, that I don't know. I'm not sure I personally would call them homographs, but so some of you may talk about your aunt, and others may talk about their aunt. That would be a case of a homograph. But here, notice we have this, which is the boundary of G. But you could also talk about, something like del G here as, or Z, sorry, as differential of Z. Okay, so you might see something like, right, from calculus, you see something like that. Partial of Z with respect to X. Okay, so that was one example, but actually I never really mentioned the other, right, which was Z bar, and that is the conjugate of Z, X bar, which we usually mean as the sample mean of X, a set X. But then, we could also use, something like V bar, a notation for a vector. So, math, I often say math is a language, and, languages have these things like homographs. And so, it takes context to make sure you know what you're talking about. And sometimes you can get confused because maybe there's not enough context. Okay, so enough about the homographs, but, I think that's a good thing to realize. Okay, so that was the boundary of a set G. The interior of G is the set of all interior points of G. And the closure of G is the union of the sets G and the boundary of G. So it could be that G is closed, and so it contains all its boundary points. So in that case, right, G closed implies G equals G union the boundary of G. Okay, but certainly that wouldn't be true for an open set, and a set that's neither open nor closed would that be true. And so, for instance, they mention that, if we let G equal the open disk AR, then the boundary of G is equal to C AR, the circle going around that open set, and the closure of G is equal to, well, I'm not going to put that equal sign there. That could get confusing. Is G union the boundary of G. Okay, so again, remember that D, A, R is equal to the set Z element of the complex numbers such that absolute value of Z minus A is strictly less than R, and the boundary of D, AR, is then C, AR, which is the set Z such that the absolute value of Z minus A is equal to R. And then DAR union CAR is equal to the set Z in the complex numbers such that the absolute value of Z minus A is less than or equal to R. Okay, so there we go. There's open and closed and some of the items that go with it.